let's continue to this chapter 3 tutorial. Now it's part 2. We will discuss 3 types of the method that you can combine object within OpenSCAD. First is a union, so that's the joint. Difference is from one object to deduct part of those the common parts. Intersection is another direction from the difference is the left with the common part. So what we will follow this is first let's make our new model. So and let's save this as part chapter 3 part 2 first. Let's talking about the union. So as mentioned here, union is you join that. So it's two type of joint. One is the implicit, and the second is the explicit. So implicit is you don't need to use method, but if you put the two object that they covered each other, actually the result is looks like they are they are joined each other. So, but actually, this two object is not union. But when you print that, is they are put together. But from the model itself, they are still two object. So first is let's see. So union of two sphere implicit. So I put this just into one the model. So first is you create one the radius 10 the sphere. So I don't make those surface smooth. So let's leave that. Secondly is we have the copy this. So if you preview, they are just in the same location, so we need to translate. And we translate is 10. So when you translate that to another the direction, so from X we go to 10, from Y 0, Z 0, and we put this tab. Now, what's that mean? So, if we put this transparent for the first one, it's the percentage. Now you can see the second sphere is inside into the first one, and if we put that. So this point is the highlight, but what we want to do is transparent. So transparent second, but you cannot see the first one. So if we make the first one not transparent, you see here they just overlapping from the space. So they looks like it's a union, but we don't use any method to make them union. So that is the implicit way. So let's put in that here and make smaller. Let's translate them to the bottom. Then we will go to the second phase. So if I want to do the 0, just want that to the minus 25, for example, or maybe 30. But remember, if I want to translate their together, it's better, not better. You must have this the parentheses to make them. So that's like this way. So I move them in a little lower. The reason is let's go to the second part. what's mean the union of two spheres? Explicit. So which means is we have two sphere. So first is we have a sphere r equal to 10. So that is our the first one. I should have a semicolon. And then is I have translate 10, 0, 0. Just repeat what we did in the first model. So we have this. Now what we need to do is we're starting to use this function union. Because it's a function or method, you should have this open and close brace. And then this what we are going to union is this block. So we need to have our this brace, the parentheses, so brackets to cover this two. Then what we have do the preview. So now you can see here. Let's try to make this transparent. So you can also see they are looks like it's the same. So that means is you get the same result actually, but you get this same result by different way. So the union is explicit is using this union command. So the union command doesn't have any input parameter, so it just are blank within this curly. So the open brace and the closed brace. This is true for all the balloon operation. Balloon operation is one union another, or one deduct another. So you don't need to have any the parameters inside. And the union is applied to all objects inside the curly brackets. So if you could put these the curly braces, then they union that. But if you want, you have another the cylinder. Let's see, the cylinder is height is in the X part. So let's see, we have 40 height. R is the bottom R, the radian, and R2 is the bottom radian. So if I say I have 10 and 5, so that like are not the same. So I see. So we will also put this union together with this two. So then you have this a little complex shape. Just put them together. If you write this mole shape, they just continue union as long as they are in these curly braces. This is within these brackets. So that's the union. So the syntax is similar to use the transformation when applied to multiple objects. So and that is the union. So we put this as the first model. So let's save this, and we let me save, and I make our new model. So let's go to the difference. So let me save our new model. So let's see. So difference. So that's the to see. So first is let's have our sphere. So you remember is I can have this R equal to 10, but I can just make the R invisible. So so save that R, but that will be the same. So first let's get the sphere. Then this let's get the second sphere. But I translate translate this to 10. Oh, now it's maybe 12. And I go this, and let's see. So we have these two joined or union. But instead we use union, we put this difference. And then let's put that here. Give this the parenthesis. So let's see what we get. Is the second part is actually like a knife. So they cut the first object, and the first object's the left part, which not covered by the first the second one, will be left. So that's the difference. Like the mathematics is the A minus by B. So the union like is A plus B. So this difference is as A minus B. So that is the way. So looks like if you, but if we have the 10, so you can see just make that more deeper. So we save as this 12. So that is this model. And that is the difference of two spheres. Let's put that is a difference of two spheres. So what about the three sphere? So if we have one more, so then how that means is let's make this one translate. Like what we did is 0, 0, minus 30. Because it's a difference is one the function and method, and they have our the parentheses, and it can be read as our one sentence or one statement. So you don't need another parenthesis to include that. So that, but it's better if you have to translate, make that into the tab. So now we put that lower. So what I want to do is I need another model. So, but this model is I don't need to translate first. So let's make them back. So we have this. The A minus B. So what means the 3? So that means is let's create another sphere, but this sphere is we want this sphere is cut from this area. So that means is we need to move this sphere, the third sphere, from y-axis. So not this, but we come to is y minus 12. So let's see. So you get this one. So similarly, is if we just cut, so we can have another 2. If you just want to play, so if we want to cut from x minus y positive, that means that we have 4 spheres cut this one. So it's like our the apple you finished eating. So that is interesting. So what about this? We also cut from z. So let's see. So 0, and we have our positive 12, and here is 0, negative 12. Let's see. So you get something is more interest is not connect anymore. So that is the cut it by 6 the sphere. So that let's make it our function. So the perimeter. So the offset. Let's see. I make this maybe it's 14. So because I want them is can be the connect each other still. So let's see whether we can have that. Replace all the 12 by the offset. So now you can see you can now see this 6 sphere cutting. It's lucky is the bottom sphere is not overlapping to this one, because if you want to double check is you can give the percentage. So that is the bottom one. So you see here, because it's minors, so that is inside the second paragraph is not, we don't have this translate to minors from this one, but just for safe, let's move that bottom further. So you can see, so you have those, let's make your sphere appear. So let's make that 4 appear. So now you know how these the difference is working. So you have those ball, and those ball is actually is from the second to the last is will be with the minors the processing. The first one is what your original or your base object, and will be minus the 1 by 1. So the third Boolean operation is the further defined. The third one or fourth, the following example has 3. So no matter how many, you have the first one is the base, and the rest of that is the minus in sequence. So that is the processing or the method for this difference. So if you see here, I make them invisible, then you can see how that will be minus. So let me save this, and we go to the third Boolean. The Boolean operation is the intersection. Let's create our new file. Save as. So what's the difference between difference and the intersection? Is difference is you have that deduct from the first one. Intersection actually is the common part. It's like the and. So intersection of 3 sphere. So first is let's go to the 3 sphere. So let's copy this. So you will have 3 here, and we will do the translation. Translate first is go to the X, and then go to the bottom. So let's see, so 1200. And what we translate is this second one. Now you see here, so let's put the axis here. You can always copy something to save your time. So we have this 0 minus y, then we have this 3. So what I want to see is these 3, they have some common part. What's the common part? Look like it's this area. So if I put intersection and with parentheses, what's that left? So you see here, that's the common part for these 3 sphere. So that is the one part. And if we want to see the 2 sphere, so let's make this translate to the bottom. Minus 40. So it's just the bottom. Then let's copy this. So I have, if we see the two spheres first, so then we don't have this second one. Then let's not translate. So you can see here. So that's the two. And then if you have one more, you get another common to do this intersection. So that's these two parts. And then we will use the next part to do this exercise, because this exercise is interesting. Try to practice your these three combination or the such kind of processing the different object, and to make some change or improvement of your car model. See you in the next video.